Blockchain is quite complicated, and it often happened that I gave an interview to journalists for an hour and explained how blockchain technology works, and finally they asked questions like, but why is it so expensive to use blockchain? Why does it waste so much energy? Why is it so slow? And then I discovered that it's really difficult to understand how blockchain technology works, and that there are still myths which are really difficult to explain and to understand and to avoid and to overcome. And this is why I would like today talk about these myths and try to explain in more detail what people mean if they say blockchain is slow, or what they possibly misunderstand if they think that blockchain is slow, or whatever the myth is. And this is what we are going to see today. Let's start first with the misunderstanding that blockchain is slow. Blockchain is slow. Yeah? So blockchain is not a transaction processing technology which realistically can achieve thousands of transactions per second in a sustainable way. But what do people mean if they say blockchain is slow? Usually they refer to the mother of all blockchains, to Bitcoin. And Bitcoin is slow in several manners. Bitcoin is slow in terms of transactions per second. Yeah? This is 5 to 7 Bitcoin transactions per second which can be processed. And that is not really very many. Yeah? So the reason is that the consensus mechanism doesn't really afford for more transactions. And the way how blocks are created and the block size doesn't allow for more. But people specifically refer to Bitcoin. And if you also look at Ethereum, the number of transactions is round about 15 to 20 transactions per second. That is also not yet so many, but on the other hand, this is a sustainable rate. Yeah? So if you multiply the 20 transactions per second times 3,600 seconds per hour times 24 hours, then you have already a large number of transactions per day. But this is absolutely not comparable to systems like Swift, for example, which have a throughput of about 25 million per day. Yeah? This maps to a bit less than 300 transactions per second. So this is just one magnitude higher compared to Ethereum. And then there's a second aspect when people say that blockchain is slow. And that is the time until a transaction is permanently stored in the blockchain without being changed, or without the possibility that it may change. And that has to do with the block time. In case of Bitcoin, the block time is 10 minutes. Yeah? Every 10 minutes on average, a new block is created. Could also be 2 minutes, or it could be an hour, but on average is around about 10 minutes. And that's not all, because there could be a fork. Yeah? There could be 2 blocks created exactly at the same time in parallel. And then in the community of Bitcoin nodes, which are about 10,000 or 11,000, the 2 concurring blocks may exist for another 10 minutes until either in the one camp or in the other camp, a block is added, which will then also be accepted by the opposite camp, so to say. In the worst case, this may take a couple of generations of blocks. So people say after an hour, you can be really sure that whatever ended up in a given block will also end up in the Bitcoin blockchain. So there is no possibility to have another fork after 6 periods of a block time of 10 minutes. And of course, this is quite slow if you look at it from a technical perspective. But if you look at it from a business perspective and think about the transaction duration, if you do an international money transfer from wherever, Germany to India, between persons, this would take days. Yeah? Compared to that, it is fast again. And then the question is also, what is the technology, the underlying technology of the blockchain? I talked about here now about Bitcoin and Ethereum, But if you look at other blockchain technologies which use a different consensus protocol, like proof of authority, we have a much faster block time. If you look at Tendermint, for example, which is based on PBFT, practical Byzantine fault tolerance, in that case, we can tune the block time down to 1 second, which we did in our projects like EnerChain or GridChain or ETBlock or New4Zero. And why is that possible? Well, it's possible because we don't use 11,000 nodes, we just use 7 or 10 nodes. And the details are described in the Tendermint video. But here, we can drive down the block time because we have just a few nodes, and the coordination for the consensus process among these few nodes is much more reduced. Yeah? It is a complex process. There are waves of messages being exchanged. The consensus itself takes a couple of 100 milliseconds, but it's milliseconds. Yeah? We are not talking about minutes. We are talking about hundreds of milliseconds. And in that sense, looking at the block time, Tendermint is much faster. And also, if we look at the transaction rate, with such a system, we can achieve a transaction rate of 50 or 100 transactions per second at the application level, meaning that beyond the actual consensus mechanism, there's a stack of applications on top of that. And if we measure from endpoint to endpoint, from client application here to client application here, the messages being exchanged through the blockchain end to end, if we measure here 50 to 100 transactions per second, this is already a very high rate, yeah? Specifically compared with Bitcoin and Ethereum. So it's a myth that the blockchain is slow. It depends on the technology, and there are technologies where the throughput is much faster. So that was myth number 1. And now, funnily, the myth number 2 is that blockchain is fast. Yeah? Now, this is exactly the opposite side. Yeah? There are people who promote their blockchain technology who say, oh, our blockchain is able to perform 10,000 transactions per second, or 25,000, or 100,000, or even 1 million per second. Yeah? And if you think about it, let's say 100,000 transactions per second, and imagine the number of seconds per year, and just let's assume that this is maybe 100 bytes per transaction, we will end up per year with petabytes or thousands of petabytes per year. Yeah? Okay, maybe that makes sense, and maybe we find such a situation in the case of Google or other huge databases. But in case of blockchain, I think that doesn't make sense, provided even that 100,000 transactions per second would be possible. Yeah? Realistically speaking, if we talk about blockchain, we talk about blocks and about chains. And a chain is a string of blocks. Yeah? So there's always one block after the other, which means that we have a certain level of centralization. Yeah? Blockchain is called a decentralized technology, but if you zoom in and if you understand how the consensus mechanism works, you easily see that there is often just one coordinating the process, being the proposer of the next block. Yeah? If we have a look at proof of authority consensus mechanisms, there's a dedicated role who is the proposer, and this specific role is one out of the many validator nodes, and this one coordinates the process of finalizing the current block. So that is a limiting factor, and that reduces the scalability of blockchain technology. And if we define blockchain as something based on the chain of blocks, literally speaking, then there is an upper ceiling as far as the transaction and performance and transactions per second are concerned. Realistically speaking, as I said, this might be 100 transactions per second. Maybe it can be tuned a bit more, but if it is tuned even more, this would mean that we reach lab conditions. Yeah? If we use just one node. Yeah, this is not a blockchain. Yeah, there's nothing which is distributed anymore. But let's assume if we use one block, and let's assume that the validation doesn't take any time because it's an empty validation. There is no validation applied, and let's assume that the communication bandwidth, we just don't need that because there's just one node. Yeah, and let's also assume that this runs on a physical processor at high speed, yeah, then we can indeed achieve 10,000 transactions per second. And we tested that with Tendermint and it worked, yeah. But this is not blockchain. This doesn't allow for deploying redundant nodes, yeah. We don't have a redundancy. We don't have the possibility to deploy the node at different organizations such that one organization may fail technically or organization-wise, trust-wise, and the rest is still able to persist and to continue running the blockchain. So in this case, in this lab, under lab conditions, we did achieve 10,000 transactions per second with Tendermint. I think it was even not just one node, but two nodes, but very closely co-located. That is possible, but it's absolutely not realistic. And if other technologies claim to process 100,000 transactions per second, usually this is not a blockchain consensus mechanism. It might be a distributed database like Kafka or like other technologies available, like Cassandra, for example. But it's not a blockchain. And let's be agnostic here. If it makes sense not to use a blockchain, this is absolutely fair enough. Yeah? Use Apache or use Kafka, use Cassandra, fine. Yeah? But then don't call it blockchain. That's actually the myth, yeah? That blockchain is able to process 100,000 transactions per second. And then there are other technologies like Hedera Hashgraph, for example, or technically speaking also IOTA, which are not blockchains in this sense of having a string of blocks. These technologies also have the potential to be much faster. Yeah? This is also fair enough. We may reach 100,000 transactions per second. But the main point is blockchain technology will not really go beyond maybe a couple of hundred transactions per second. I think that is a very general misunderstanding, and people who do blockchain projects, they practically understand that as soon as they do such projects.